Let me introduce the next presenter, Mr. Chameera Udawatthe. The subject is on low energy architecture. He will be presenting a building section for passive climatic modifications in Sri Lankan non-domestic architecture. Mr. Chameera Udawatthe is an undergraduate student of University of Moratuwa. His research interests include construction technologies, climatic sensitive designing and ancient architectural sciences. He is currently at the final year of the undergraduate degree program led by the Department of Architecture. Chameera, it's your floor now.
Thank you, madam, for the introduction. This is my third year research. I'm from University of Moratuwa. Our university monthly current bill is 96 lakhs. So it's a very big amount. Out of that, 46 lakhs goes to air conditioning the buildings within the university. So which is a massive amount. If we use that, we can buy a car every month. Have you heard that cars doesn't consume more energy? Perhaps buildings consume more energy than cars. This is a fact because of the construction as well as services that include into the process. Not only that, buildings contribute more into environmental pollution. So it provides form of a carbon footprint and it helps to reduce the environment. Can you stop this? What are solutions? The solutions that should come with the environment itself, or else introduction of new technologies, new systems. So that will lead our earth to a sustainable thinking. So the solution is, as we are building buildings, as we are designing buildings, we can do it in such a way that provide and accommodate good services. And I found that through the literature, the best way of doing this is passive climatic modification. So to introduce the passive climatic modification, I use this example, diabetic. You all know diabetic. Diabetic is illness. You have sugar in your body. The passive system is the body itself provide a mechanism to reduce the amount of sugar in your body. But an active system, it is like air conditioning. We have to measure how much blood in your body and you have to put in insulin and you have to control. So this is a good example for you to identify what is a passive system as well as what is an active system. In the building context, igloo building, I think you have seen in Eskimo North Poles. This is one of the best example for a passive building. You may not have noticed in the cooler climate, these buildings are much hotter than outside. They are retaining their own energy to keep them much more comfortable. Not only that, these are designed into their comfort. What are the advantages? There are lots of advantages. The key advantage is that minimize the services cost. That brings air into the building, that brings light into the building, which that process helps to minimize the services cost. Such as we don't need ACs, we don't need fans, lights. It gives a form of a new building that combine man and the built environment. And also finally, the passive systems can create a smart and sustainable building. You know, we all talking about the sustainable qualities and sustainable environment and sustainable future. But our thought is not yet finalized. In order to apply these passive systems to buildings, through the literature I have found that there are three key methods. One is we can use the plan form of the building. The other one is we can use the sectional form of the building, or else we can use the building envelope. But for my research I have used the sectional form, which has advanced effect because it talks about the outside environment as well as the inside environment. In order to find out, I find 3 case studies from our country, from Colombo, in a very hot humid climate, that are suitably celebrated within our community as cool buildings. I mean, cool buildings is, they were awarded as best examples for these types of climatic modification. My case one is from by architect Kiranti Velandawa at Hyde Park Corner, which is a very hot environment in urban landscape, and it's an institute which is more into dancing activities such as their ballet and all. And the other one is Chitrasena and Dance Foundation. I have taken similar types of case studies. And the other one is the Royal College Canteen, which also celebrated in 2009 as one of the best ventilated building. However, we have identified their sectional strategies they have used to minimize these kinds of energy consumptions. So the first one is they have used thermal mass. Use of thermal mass, they have oriented the building in such a way, and they have provided different types of envelope strategies in order to minimize the heat gain to building. And the front facade, they have used cross ventilation techniques, open the building facade. And the interesting fact is, this is one of the best example for you to identify what is a thermal chimney. Thermal chimney is an interesting fact, like it used the heat itself to remove the heat within the building. So it creates different pressure variations and it moves air circulation within the building. And also they have used the greenery to diffuse the solar radiation. It's like solar radiation directly come into building. You reflect through a green layer, so it doesn't come into a building direct way. And the case 2, they have used the thermal mass as well as cross ventilation. Thermal mass they have used for the orientation, the east-west orientation to the west, they have used thermal mass, so it doesn't get direct solar radiation to the building. And this is a form of a very open envelope where you can get the natural cross ventilation. But there are issues and problems with these buildings that will lead to an uncomfortable environment within the building itself. And also they have used the green as a shading equipment. So when the sun rises from the morning, you don't get enough direct solar radiation to the building. So in the morning, building is cool itself. And for the west, that is the most dangerous time where you get the bad solar radiation, and they have covered with the use of massive thermal mass. And also the use of materials in the sectional form. They have come up with the different solutions to justify these kinds of techniques that they have used. And the case 3 is the Royal College Canteen, which is we have selected why it's a colonial design. Colonial is smarter than us today, and they have used the thermal mass and the signal side ventilation. And also the best strategy they have used is air funnel as a passive technique. So what they have done is they have created a pressure variation within that microclimate, so then air travel through the building and it gives us form of a very comfortable zone the building itself. Coming back to the findings, what we have done is we have measured the thermal quality of the building. As you have seen in the previous presentation, which is what we have done is, which is not only the temperature, we have measured the humidity as well. Because humidity is talk about the ventilation, but end of the day we should measure how much it is comfortable for you, how much happy you are within the building, which is not only the temperature in Sri Lanka. So collecting thermal data, we have used hobometers that gives you indication of hourly temperature of humidity as well as the temperature. So and then we have analyzed those data and come up with the solution. These are our results findings. First we have measured how it is comparatively different from outdoor to indoor. How much these sectional forms apply in these things. So the case 1, it looks morning it is good for the building user, but then again the indoor temperature goes up accordingly. And also the case 2 and 3 also form of same results, but coming back to humidity, the humidity itself shows a different scenario, but also humidity follows the temperature itself, because when the temperature goes up, humidity comes down. And here in the evening, in these 3 cases, the humidity level goes down, but there are some exceptional cases like case 3 where they have introduced lots of greenery and their humidity level is very higher than the outside. And case 3, the canteen, which is a better solution because the peak cover from 10 to 16, which is very comfortable for the user because humidity goes down as well as when the temperature is going up in the afternoon. The discussion is, instead of describing this temperature and humidity, we came up with the formula that talks THI analysis. THI analysis talking about the temperature humidity index, which means it analyzes temperature as well as the humidity. So that gives a range where you are comfortable. The comfort range is shown in the red dotted line, and the case 1 blue, case 2 is green, case 3 is red. So you can see that case 1, the modern building, which has more advanced effect than the other cases, but the case 2 and 3, especially case 2, which is not comfortable for the user in the daytime from 8 to 20, which is not comfortable for the user. So this is an interesting finding that use of passive systems alone cannot sustain a building for a comfortable situation. So which means we have to introduce another system which is active. So what my finding is talking about, use of passive system as well as active systems, we can enhance our indoor climate or indoor environment or indoor thermal condition. But the modern trend is different. We are talking about these green facade and green techniques. So which is not the way. The use of passive systems as well as use of smart active systems are the best solution for a green building, because as we have already mentioned, green is not growing green. Green is all about use of these technologies, passive systems to cool your building and be a happy environment. Which is like this, you have to analyze, strategically use the passive systems to enhance your building, which is not use of green, which is like a sectional form. Thank you.